Hi friends, how are you doing? Welcome to my YouTube channel to watch this sequence of videos on Python programming. In this video, you will learn about the concepts behind iterators and generators and their usage with the help of simple relevant code example. Shall we begin? Now we will learn about iterators and generators broadly, but in specific we'll learn what is an iterator, what is an iterable, and what is an iteration, the difference between all of them, and what is an Iter protocol, and what are iter and next functions, and the dunder methods double underscore iter and double underscore next. We'll also learn about generator, the generator function, and the generator expression. Now, as you know, iterator in Python is simply an object using which you can iterate upon a sequence of values. You can traverse through all the values using an iterator. But technically, iterator is an object which implements the iterator protocol using the double underscore iter and double underscore next methods. You know, iterators are present everywhere in Python. They are even in for loops, comprehensions, generators. Iterators are literally present everywhere. Let's look at the simple example for an iterator before we proceed. But in order for an iterator to work, it should be created first. So what is an iterable? An iterable is something from which you can get an iterator. For example, a list, tuple, set, dictionary, and string, they're all iterables. If you pass this iterable to an iter function, then you get an iterator. Now let's see with an example. So here we have new list. This is an iterator. This is a list and it is an iterator. Here we have new list and this is an iterable. Now we are passing this new list to the iter function, and what the iter function returns is an iterator. Iter and next functions, they form the iter protocol. So let's see this with an example. Now here is the iterable, the new list, and we are passing the iterable to the iterator. Here is the new list, which is an iterable. We are passing the iterable to the iter function, and the iter function returns an iterator object, which is new iter. So let's run this to find out. So as you can see here, this is the iterable, the new list, and that is passed to the iter function, and what we get is an iterator. If you first call the iter function, what you get is an iterator, and then subsequently you call the next function on the iterator and it prints the successive elements of the list. So as you can see, apple, banana, and cherry are the successive elements in the list, and it gets printed when we call the next function on the iterator. Now just to show that the new iter is indeed an iterator object, it's an iterator object, so we can actually print the new iter to check that it is an iterator object. Here we go. So as you can see, this is an iterator object and this is returned from the iter function, which takes an iterable as an argument. This iter function in turn calls the dunder method double underscore iter. So what's important and fascinating to note is this iter function, okay, when you pass an iterable to the iter function, what you get is an iterator object. But this iter function here actually calls the dunder method double underscore iter double underscore. Now if the double underscore iter exists, then the iter function calls it. Then if it doesn't exist, then it checks if there is a method double underscore get item. If double underscore get item is present, then the iter function creates an iterator object and returns that object. If both are not present, both means if double underscore iter as well as double underscore get item both are not present in a class, then it raises a type error exception. And the other thing that was mentioned here, as you can see, is the iterators are present everywhere. In fact, when you use a for loop or a comprehension or a generator, which we are going to see shortly, internally they call the iterator. In fact, the for loop also calls the iterator behind the scenes, which we'll prove by the way of an example. In fact, a list is an iterable, a set is an iterable, everything is an iterable, and if you pass the iterable to an iter function, what you get is an iterator. So these are the different types of iterables. Now you can create this yourself by using a class. Now let's create a class that outputs the power of 2 one by one. Let's say that I have this class and in the constructor of the class, this is the power of 2. In the constructor of the class, I initialize till what number I want the power of 2. And in the iter, as you can see, it creates an object and returns the self after initializing the value of n as 0. And the double underscore next method steps through the n value and then produces the 2 to the power n and returns the result, which is the 2 to the power n. And if the maximum value is reached, then you can stop the iteration. Then an exception is created, the stop iteration exception. Now here we are actually creating the object for the class. Here we are creating the object for the class. This returns the object, and this returns the iterator object. This returns the iterator object after initializing it with the number. After initializing this with a number, as you can see, so I have the numbers, which is the object here, and this object is passed to the iter function, and what I get is an iterator. So if I run this, as you can see, I create the 2 to the power of 1, 2 to the power of 2, 2 to the power of 0 is also there, in fact, up to 2 to the power of 7, because the max value was initialized to be 7. So you are initializing it with 7, but the default value of max is 0. If you don't give anything, it is 0. But here we are giving the max value of 7. So the object of this POW2 POW2 class is created, and it is passed to the iter function, and therefore we get the iterator. So this is we ourselves creating a customized iterator by using the double underscore iter and double underscore next methods. It's a customized iterator creation. So this shows that by using the double underscore iter and the double underscore next methods, we can beautifully create a customized class iterator. So if you call one more time, that is 8 times, then obviously you can see that, so it raises stop iteration. So if you call only up to the prescribed number of times, then there is no stop iteration created, and it works like a charm. I also mentioned that the for loop in Python uses the iterator behind the scenes. For example, here is the for loop that actually goes through a list. Here is a for loop again that goes through a tuple, and here is a for loop that goes through a string. So you can see that in the string, one character after the next is printed, and then the other two, you can see that it prints the elements of the list. Now, one interesting thing in this for loop is, you can see that this for loop, which prints the elements of the list 1, 2, 3, actually can be replaced by a while loop with iter and next functions. So here I have this iter function which takes a iterable. This 1, 2, 3 is the iterable, and it is passed on to the iter function, and as you can see, this it is the iterable, and I am using a while loop to go through this using the next function, and I also get 1, 2, 3. Now there is a proof that for loop indeed uses the iterator beneath. So I have created a demo of the iterable and the iterator. So I am creating random numbers from 1 to 10, and if the number equals, the created random number equals 5, then a stop iteration exception is created. Now here I am using a for loop, and this is an iterable demo. So this is the demo class. An object of this demo class is created by this iterable demo. So here I have this iterator, and then I use the for loop from the first to the last one. I print all the elements. So as you can see, this for loop actually uses the, let's run this to find out. Here you see there is this for loop is using double underscore iter and double underscore next functions beneath. So we are running the for loop, but it naturally calls this double underscore iter and double underscore next. So this small code sample is a proof that for loop internally uses an iterator. So I hope this is very clear for you, that how the iterator works. Now what is a generator? As you can see, this function is a generator. You can say this is a generator function. So what do you mean by that? if the body of a function or a body of a def contains at least one yield statement, then it automatically becomes a generator function. So if you want to understand what is a generator, so Python generators are functions that contain at least one yield statement. Yield is actually like a return, but yield will return the value and it will start, next time you call the function, it will start from the point where it left in the previous call. So yield will return, and then if you call it again, it will come back and execute from the same point again till the number of elements are exhausted. So that's the difference between yield and return. But if you return once and for all, it is returned from the function and the stack is cleared. But here in the yield, it returns the value and then waits for the next call so that the next sequence of elements are also returned, right? And it has at least one yield statement in the function. And what does yield do? We'll have a look at it now. Now here I am actually calling this cubes function, and as you can see, this is a generator function because there is a yield statement in it, and what I get is a generator object. So what is a generator object? Generator object is nothing but an iterator. So what is an iterator? Iterator is an object using which you can traverse through the elements and print them. So in other words, generator is also functioning like an iterator if you use appropriately. So this piece of code is what you call a generator function because there is a yield statement in it. And if you call this generator function, what you get is a generator object. And using the generator object, you can sequence through the elements and then print till the end. That's a generator function, right? And there is the next, the generator expression. So this same thing that we show here as a function, the same thing that we show here as a function can be expressed as an expression also by using a tuple. So here we have a tuple where n to the power 3 is created for the numbers 0 to 9. So you're going through a for loop, and then this cubes is what you call as a generator object. So this is a generator expression and this is a generator object. So by going through this, we are able to print the elements in sequence. So generator expression is an expression that returns a generator object. So this is a generator expression, what I'm highlighting here, and this is the generator object. It provides us with a simpler way to return a generator object. So what provides us as a simpler way? Generator expression gives a simpler way of getting a generator object. So I hope you are able to understand the difference between a generator function and a generator expression. So this is a generator expression and you have to use the tuple syntax for that. So some people think this is generator, this is tuple comprehension. Actually, tuple comprehension is not possible because tuple is immutable. And this is nothing but a tuple syntax, but it is used for generator expression. And this one is the generator function. Now let's see how the generator functions by using a simple example. Now here we go. We have a generator function and we call this generator function cubes by passing the value of 10. So we get a generator expression. We get a generator object. So let's print that to see indeed it is a generator object. So this is the generator function and this is the call to that function which has one yield statement. So that is a generator function, and what you get is a generator object. As you can see, this is a generator object cubes, right? What you get is a generator object. Using a generator object, you can actually go through the n to the power of 3 till 9 you can go because you have this 10, so you can go till 9. So as you can see, it prints the n to the power of 3. Now the same thing can be achieved by using generator expression example. As you can see, this is the generator expression, and what you get from the generator expression is a generator object. So once you have the generator object, you can go through the for loop to print whatever is given as a rule in this expression. So which is nothing but n to the power of 3. and here I get from 0 up to 9. So 1 power 3, 2 power 3, 3 power 3, 27, and 3 power 4, and so on. So you can get the complete values. So whatever n value you are passing, so it will be given the power. So first we are passing 0, 0 to the power 3 is 0. Then we are passing 1, 1 to the power 3 is 1. Then we are passing 2, 2 to the power 3 is 8. Then we are passing 3, 3 to the power 3 is 27. 4 to the power 3 is 64, and so on. So this is a generator expression, whereas this is a generator function. So hope you got the concepts behind iterators and generators and how to use them in this video. So if you found this video helpful, please give a like and subscribe, and also please share your comments in the comment section below. Thanks for watching.